Good morning. We have been discussing about the payments, type of payments. There are two types of payments as said, flexible payment and rigid payment. The structural design of the payment is called payment design, and another aspect as far as the payment is concerned or the roadway is concerned is its geometric design. So there are two types of designs for the roads, the structural design for the pavement and the geometrical design for the roads. There are different methods of designing the structure of a pavement. So in the flexible pavement you have different layers. In rigid pavement you have a single layer for taking the load and one layer for the riding surface. So first let us see what a flexible pavement comprises of. The bottommost layer, as you have seen, is nothing but the formation. That will be, once you fix up the alignment, then you just remove the topsoil, then whatever objects are there around the roadway to be constructed will be removed, and you get a land which will be compacted, which will be mechanically compacted, which is known as the formation, over which you will have one layer which is known as the subgrade. Subgrade, that you have to have a layer. The thickness of the subgrade depends on the load coming over the pavement, mainly the traffic load and the corresponding factor of safety. Subgrade, over which you will have one layer which is optional. It's a compacted subgrade. A subgrade over which you will have a compacted subgrade. Then over which you will have a base layer. So subgrade, compacted subgrade, base. Then over which an optional layer which is known as the subbase. So this compacted subgrade and subbase are optional according to the intensity of the traffic and the type of the soil by which you are forming the other layers. Over the subbase, obviously you will have the wearing surface or the riding surface. So components of a flexible pavement are subgrade, compacted subgrade, base, subbase, and the wearing base. You have to give a corresponding cross load. That is the cross section of a flexible pavement. In the case of a rigid pavement, you will have the formation which will act as a subgrade. Formation, if it is stabilized, it acts as a subgrade, on which you will have a thick concrete layer. Concrete is the usual material for the rigid pavements. So you will have a concrete layer. Then the concrete layer itself you give for the with the geometrical designs as the riding surface. The riding surface also can be the concrete layer. Usually in the flexible pavement, the riding surface will be bitumen, asphalt or tar, which is technically called bitumen. There are different grades of bitumen and the standards. Usually, colloquially, you call it just tar roads. Flexible pavements will have a top, and the top is nothing but the tar roads. Below you have, in the subgrade, you have weaker soils. Whenever you are going nearer and nearer to the top layer, you have stronger soils. You may be using the granite pieces to ballast. You will be using granite pieces too, ranging from a size of 80 mm at the lower level, going on to 60, 40, 20. with different thickness. Usually the road cross section, if you see it, the sides will not be exactly vertical. The sides of this will be a trapezoid to take care of the stability of the slope, because these are all loose material. Even though they are compacted, there is a chance of these materials sliding down because of friction or lack of friction, to be more precise. So they'll slide down. So to take care of that, you give a slanting slope, a stability of slope, considering the stability of slope. You give a slanting edges, sides, usually called the embankment. So the road embankment having subgrade, compacted subgrade, base, subbase, and the wear and tear. Then obviously at the sides of the embankment you will have the drain. Then it goes the other upper drains such as curb, shoulders. Shoulders may be the dedicated footpaths or additional footpaths. Then you have separators, dividers. Then you have to have traffic islands to negotiate the traffic, the directions of the traffic. Then you should have the space for the arboriculture as you have decided. Like that, the road construction goes. I don't want to go deep into that. Our idea is to see what are the various civil engineering practices going on around us. So that is a flexible pavement. And there are different methods to design a flexible pavement, such as group index method, California bearing ratio method. These are the two usual methods to design. Design of pavement means fixing up the thickness of each layer. By getting the values of these materials in the laboratories, you have the group index values, you have the CBR, usually called as CBR, the California bearing ratio. Different layer will have, according to the material, you will have different CBR values. That CBR values will decide how much thickness you require for the type of loading coming over and anticipating the future traffic too. A dense concrete thick layer will be there for a rigid pavement. On a very compacted subgrade, you form a layer of thickness, sufficient thickness. In the flexible pavement, usually joints will not be there along the length, the longitudinal line of the pavement. You will not have joints because it is flexible. That is why it is called. In rigid pavements are susceptible to temperature variations. They are rigid, so they are subjected to they will be subjected to elongation where temperature is more and contraction when temperature is less. So this elongation and compression will result in cracks. So anticipating this, usually in rigid pavements, you will see joints. You provide joints, otherwise already a crack will be formed. Cracks are nothing but forgotten joints. If you forget to provide a joint, then that joint will automatically come as manifestation naturally as crack. So these joints are called expansion joints. So one type of joints in rigid pavements are expansion joints. In the region of cold, it will be contraction joints. When the temperature or snow load is more, and if the rigid pavement is shrinking, then you have to provide for contraction. So expansion joints, contraction joints. Then construction joints. You cannot complete the stretch of the road in a day or two. So several days you have to break the work. So conveniently you provide for the continuation of the next day's work, you provide construction joints. So construction joints, expansion joints. then the contraction. Then in rigid pavements, sometimes you have base, BAYS. You just make base. So all around that you have the, if you have a width of for a single lane traffic, if suppose you have two pieces, and at the center you have on either side. So you make, so that is a join for the formwork. So formwork joints may be there. So formwork joints, expansion joints, contraction joints, that will take care of the shrinkage too. Then the construction joints. So rigid pavements will be costly, obviously, because cost of cement, considering the cost of cement. So whenever the length of the road is more and more, people may obviously go for naturally formed flexible pavements, because available rocks more from the alignment itself, from the vicinity of the alignment itself, they can very well be effectively utilized for the construction of the pavement as ballast. Coarse aggregates, COARS, coarse aggregates, large pebbles, they can be used. So flexible pavements are very common in highways or any type of roads, and rigid pavements are rare cases, usually for short stretches. Sometimes you have a combination of these two. Along the length of the highway, you have flexible pavements, some part in the longitudinal sector. And then you have the rigid pavements. That is a structural design. The geometrical design of highways. One I told you, the cross slope, to facilitate the drainage. That cross slope is otherwise called camber. In a flexible pavement, the cross slope, that is from the center line, 1 vertical to 36, 1 in 36. To facilitate water, come to the edges, enter the drain. To facilitate that, you give a cross slope, which is known as. So in a mechanical construction, from the formation itself, that slope, cross slope will be maintained, and in the formation to maintain that cross slope, you have a template, and that template is known as camber board. Template of 1 in 36 will be made, and you adjust, you construct in such a way that you get a cross slope, curved cross slope of 1 in 36. The longitudinal alignment, as far as possible, if it is plain, it is good, but sometimes you may have to give a slope along the longitude also, and the longitudinal slope along the highway or the road is called gradient. Longitudinal gradient, that has to be a maximum of 1 in 50. Usually in highways, the longitudinal gradient can be 1 in 50, and the cross slope can be 1 in 36. That is one aspect of geometrical design, the cross slope and the longitudinal slope, the gradient. Another geometrical design is when the vehicles are negotiating the curves. When the vehicles are negotiating the curves, you need an extra width. Geometrically, you need an extra width to negotiate the curve. So extra widening, the excess width required along the curve of the height. Wherever you have a curve, you have to provide extra width. So that is another geometrical parameter. And not only that, from physics you know, when the vehicles are going with speed, there will be an effect of centrifugal force. So there will be a tendency for the vehicles to go away from the center because of the centrifugal force. So the vehicles have to be brought towards the center by slightly raising the edge of the road compared to the inner side. The external edge, the outer side of the road, shall be raised with respect to the inner side of the road. I hope you can visualize. That is known as, this elevation will be mathematically fixed and that comparing to the, there are equations for that, and comparing to that, that raising, the relative raising of the external part compared to the internal part only on curves is known as super elevation. Super elevation or cant, C-A-N-T, cant or super elevation. Thank you. God bless.